in this semester, what you're going to be looking at is you're going to be looking at the world on the atomic scale. So, one of the questions that we need to answer is, what is chemistry? Let's just set the tone, and so that way this semester we can hopefully elaborate on this one question, and hopefully you can appreciate the atomic world a lot more. And chemistry is the science that deals with materials in the universe, matter. Anything that's made up of atoms. And the changes that they undergo. So that's what chemistry, it's all about what happens to stuff when you do something to it, or when something's done to it. That's chemistry. Now, how are we going to think about this class? Well, undoubtedly we've had experience with different types of thinking, and you've been exposed to logic, and I just want to make it very clear before we move on the difference and the similarities between philosophy and science. Okay? Number one, both philosophers and scientists observe nature. Okay? In fact, the first theories of the atom came from philosophers back in ancient Greece. Both try to explain how nature behaves. Both love to communicate ideas. We do it in the classroom and in professional journals. Philosophers always write up their work. But here is the difference. Philosophy is defined by logic and debate. That's what philosophers get their ammunition from. Science comes out of experimentation. Okay? Scientists test their theories out on the world and see if it actually holds up or not. That's the big difference between science and philosophy. Now, how do we do these tests? How do we run these experiments? In science, we have a very, very well-defined scheme in which how we solve problems. The first is we notice that there's a problem, so we need to observe. That happens first. After we observe a lot, we realize there's a problem or there's a question that we want to answer, and then we try to come up with a working explanation. We call this the hypothesis. Now, that's just a statement that we make to try and explain the observations, and then we have to test it. And the test comes by designing a tight experiment. A well-designed experiment will help you to either confirm or deny your hypothesis. Hypotheses cannot be proven right, but then we always try to poke around at it and try to find a counterexample. And this process will repeat over and over, because in part of doing an experiment, we make more observations, we see if our hypothesis is right or not, and then we either make more experiments, or if we realize that after many, many experiments that the hypothesis does stand up, then it becomes a theory. A theory is a tested hypothesis. And theories always keep on getting tested. And so if you run more experiments and you realize that there's a particular case in which the theory cannot explain, then the theory needs to be modified in order to account for that. And then the theory, then we'll go back into the cycle of making more observations, retooling the theory, doing some experiments, analyzing the data, and so on and so forth. But there are some times when we just make a whole bunch of observations, and we realize that the same thing always happens when you do something. For example, if you let an object go, you lift an object off the ground and let it go, it always falls to the ground. Well, there is no object that will break that observation. Every object falls to the ground. And so we can make a statement saying all objects fall to the ground when dropped. That's a law. Laws are just a generalized statement of an observation. They don't explain what happens. They just say what does happen. Laws can never be broken because a law is grounded in the physical reality. Okay? So let me summarize this for you. So a law. It's just a summary of observations. You cannot prove a law. And laws cannot be broken. A hypothesis is a tentative explanation of your observations and can only be proven wrong. You cannot prove a hypothesis. Same thing for a theory. A theory is a general explanation of something. And a theory, again, can only be proven wrong. You cannot prove a theory right. Now here's another way to look at some of these terms. Okay. Okay, so let's make a little grid here. All right, so observations describes what happens to a small number of events. If you make lots and lots and lots of observations and describe what happens, that is what a law is. It applies to everything, all events. A hypothesis is a tentative explanation of why a few things happen. So you make some observations, you make a hypothesis to explain that. Well, you keep testing it, try it on many, many different scenarios, and then a theory is always more general, and it applies to all events in a particular category. So that's how we want to think about these terms. Make sure you're very clear about these terms. You can read your book about the phlogiston theory. It's an old theory of combustion that was proven wrong by experiment, and through that theory we actually came to understand a lot more about how combustion happens. Now, theories that are wrong are not all bad. We still teach in quotes theories that are wrong today, and we'll talk about that later on this semester.